Hi everyone, welcome to episode 2 of Maths with Mr. Yates, and I'm going to start with a little riddle for you. What do you call a maths teacher who makes their students calculate averages all lesson? Mean. So, there you have it. Now, we're going to be talking about averages, or rather we're not going to be talking about averages because mathematicians don't actually like to use the word average. It's not very specific. So it could mean one of three different things. It could mean the mean, it could mean the median, or it could mean the mode. And these are actually three different things that we call measures of centre. And this is a much better term to use than average because it sort of tells us what we're actually looking at. We're looking at things that tell us where the centre is. So now these ones have fairly similar names, and there is a rhyme that can help you remember which is which. And it also gives us a little instruction of how we can find it. And it goes, hey diddle diddle, the median's the middle. You add and divide for the mean. The mode is the one that appears the most, and the range is the difference between. So the range is not one of our measures of centre, but the first three are. So if we had a bunch of numbers, and let's link it to something, let's say it's the number of siblings that each student has in a fairly small class, it could look like this. We could have one child with 0 siblings, four with 1 sibling. 3 of them have 2 siblings, 2 of them have 3, and 1 of them has 5. So what does that end up looking like? So first up, we want to find the median. Now the median, as we set up there, is the middle number. And it'll be the number that has if we've ordered these from lowest to highest, the median will be the number that has the same amount of numbers on each side. So on each side of this number, there are 5 other numbers. So this is the median or middle number. So our median is 2, pretty straightforward. Now, next up, we've got the mean. So the mean, if we want to calculate the mean, we add and divide for it, which means we add all of these numbers. So we end up with 0 plus 1 plus 1. And you could do a shortcut instead of adding up all of these little numbers. And I'll show you that in a little bit. You go 1 plus 1 plus 1 plus 1, plus 2 plus 2 plus 2, plus 3 plus 3 plus 5. And when we add all of those together, you might have done it more quickly than I did there, but we add all those together and we get 21. But we've got to divide as well. So we find out how many numbers we've got. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we divide by 11. And it's good to write this as a decimal because that means it's easier to compare to other decimals or other numbers. So I'm going to call it 1.91. I'm calling it to 2 decimal places, and that is what our mean is. Next up, we've got the mode. The mode is the one that appears the most. So which one of these numbers appears the most? Well, we've got 4 lots of the number 1, so that's going to be our mode. Next up is the range. The range is the difference between the highest and lowest number. And yeah, there we go. So our highest number is 5. Our lowest number is 0. It's tempting to write 0 to 5 as our range, but as mathematicians, we don't want there to be 2 numbers to express our range. We only want 1 number. So we actually do 5 subtract 0, or whatever that number would happen to be. 5 subtract 0 is just 5. So our range ends up being 5. So these are all of our different numbers, median, mean, mode, and range. But why do we even bother having 3 different words that all mean average? And why did they decide to confuse us by making them all start with the letter M? Well, I can't really answer that second one for you, but I can give you a bit more information on the first one, because it turns out that each one's better in a different situation. So we want to ask ourselves, when is the median better? And one of the real world examples that we like to use when we're talking about median is talking about houses. So not everyone has the same size house. Some people have mansions, some people have apartments, and there are usually a lot more people living in apartments or houses than in mansions. So we're going to look at one community. In one community, we've got 12 apartments worth 150,000, 22 houses worth 200,000, 4 houses worth 250,000, and then we've got a few mansions. We've got one mansion worth 1.5 million and another mansion worth $2 million. Now, you're welcome to try to calculate the mean of all these if you want. And one of the ways we can do that, so up here, what we did was we just added these numbers together, 0 plus 1 plus 1 plus 1 plus 1 plus so on until we got the total of 21 here. But when we've got lots of numbers, that's going to be tedious. And more importantly, it's going to be prone to making a mistake. So what I'm going to do instead, or what I did instead, was I took this 150,000 and I multiplied it by 12 because we had 12 apartments. I multiplied this number by 22. I multiplied that one by 4, and I didn't need to multiply these by anything. And then what I did is I added all of those numbers together and then divided it by whatever these ones add up to. So 12 plus 22 plus 4 plus 1 plus 1, you'll have to trust me that it adds up to 40, or you can work it out yourself if you want. And if you do all that, you end up with a mean of $267,000 or $267,500. Now, where does this fit in? It turns out that our number here is actually higher than all of these three that we've got over here. It's higher than all our apartments and our houses. And in fact, it's just between the most expensive house and the next mansion. So our mean is higher than almost everyone except for the 2 mansion owners. Is this a good indication of where most of our numbers lie? Not really. So what we can do instead is we find our median, which is the middle number. And the middle number of this one ends up being $200,000. Now, even though it may seem like it might be $250,000, remember that we've got 12 lots of 150,000, 22 lots of 200,000. It's not like we've just got these 5 numbers here. We've got actually a very big list of all these other numbers as well. So our median actually ends up being $200,000. And and that number makes a bit more sense for where our middle is, because most of the people we've got here have houses that are worth about $200,000. So where do we want to use the median? When do we know it's a good idea? We usually use the median when the number that we've got is skewed. That is, there are some values that are much higher or much lower than most of the others. And that means that it will better represent most values. Another situation where we tend to use median instead of mean is when we're talking about people's incomes, because some people are millionaires, billionaires, and the like. They earn so much money that if we did the mean of all of their averages, if we took the mean of all of their incomes, we'd end up with a mean that was actually quite a bit higher than what most people end up earning. So that's a situation where we might want to use our median. Next up, we're going to be talking about the mode. So I'd like you to imagine that you've started a popular kids show called Ready, which stars an adorable rooster. And now you want to sell merchandise. Now this little picture took me all of about 2 minutes to draw up, so I hope you appreciate it. So on your first print run, you can't afford to make clothes in all the sizes that you want. So you do a little survey, and you survey a small group of your viewers to see what sizes you should focus on. And you find out that 10 of the people in your survey want an extra small, 30 want a small, 8 want a medium, 30 want a large, and 12 want an extra large. So you want to ask, what sizes should I focus on? So we look at the median, and if we tried to find the median, we'd actually end up going with medium size. But there were only actually 8 people who even wanted a medium size shirt. If you started to make your shirts all medium size on the basis that most people, or that was the middle of everything, then that's not going to be really helpful. And so in this case, we actually want the mode. And the mode is going to be the most common sizes, and there can be more than one mode. And in fact, there's a special word that we use for this type of data where there are 2 modes. The word that we use is bimodal, which is pretty straightforward as a word. Bimodal has 2 modes. So here it should be pretty obvious that we want to focus on the small and the large sizes. We don't want to go for the medium because that's actually got the most people in it. And so this is the kind of situation where it might be useful to use our mode instead of using the median or mean. So we know where we use our mode and we know where we use our median. So when do we actually use the mean in the first place? When is the mean better? So the mean is useful when our data doesn't have any extreme high or low numbers, and can give us a better idea of where the center is when we're comparing 2 sets of data. So let's go back and compare 2 classes of data. So let's go back to our first example and compare 2 classes and the number of siblings they have. So students in our first class had this many siblings. These are the exact same numbers that we had before. And then we had a second class of siblings, or second class of students, and they had this many siblings. Now, look at these. What's the difference between these 2 groups? Well, they're almost exactly the same. There's only one difference. This one's got that one there and that one there. All the other numbers are exactly the same between our 2 groups. So let's have a look at that and let's do some calculations. What is the median of our 2 groups? So of the first group, it should be pretty straightforward. Our median is our middle number. We calculated before. It was 2. And our mean, we calculated that before. I've still got that up on the right. It was 1.91. But what's our median of the second group now? Now the middle number, the median, is now 1. But what's our mean? And so that's going to be, and I'll just do that quickly, 1 times 4, because there's 4 ones, plus 2 times 2. Actually, no, there are 5 ones now. That's right, because I changed one of the 2's to a 1. 1 times 5 plus 2 times 2 plus 3 times 2 plus 5. So we've got 20. We divide that by 11. And our mean is 1.82. It averages, or when we do it to 2 decimal places, it's 1.82. So the question we want to ask ourselves is, based on the median here, this is a median of 2, this is a median of 1, is it accurate to say that students in class 2 have half as many siblings as students in class 1? Well, clearly that's not fair to say at all, because there's only one student that has a different number of siblings. And it just so happens to be that they fell on the line for the median. So it's not. And this is where the mean is much more useful. So we want to use the mean to compare these 2 sets of data instead of the median, because the median gives us a completely wrong answer, unfortunately. It is not accurate to make this sort of statement that that students in class 2 have half as many siblings as students in class 1. So here, the mean is clearly a much better way to compare these 2 classes. And that is a little bit of the difference between mean, median, and mode. So let's get on to our game. And the game we're going to be looking at is one called Mean Boxes. So in the last lesson, I taught you the game Boxes. And now we're going to mix it up a little bit with the game Mean Boxes. And it fits both definitions of the word mean. So we start with a regular 4x4 grid of dots for boxes. And then your two people will take it in turns to write the numbers from 1 to 9 in the boxes that are in the middle. So we've got our 9 numbers there. After this, we play a regular game of boxes, but there is a change in scoring. So first person may go like that, second one goes like that. The change in scoring is that the person whose mean is the highest is the person who wins, not necessarily the person who has the most boxes. So if you make a box available, the blue player now has to think, do I actually want to get this too? They may not want the two. So the person whose mean is the highest is the person who wins, not the person who has the most boxes. And just in case you need a bit of a reminder of how to calculate the mean, you calculate the mean by adding all the numbers together, then dividing by how many numbers you have. So if we ended up with, let's just sort of do this as a little example. Let's say that, come on. So let's say that the red player ends up with these numbers over here, and the blue player ends up with these numbers here. We would calculate their final score by adding all of these up. I'll do that in red just so that they're going to match. 1 plus 6 plus 5 plus 2 plus 4 plus 8. And then we divide the whole thing by how many numbers there are. There are 6 numbers in there. So I'm going to use my calculator. 1 plus 6 plus 5 plus 2 plus 4 plus 8. And then I'll divide it by 6. And we want our answer to be a decimal. Their answer is, or their result is 4.33. The blue player, on the other hand, is 7 plus 9 plus 3 divided by 3 because they've only got 3 numbers. 7 plus 9 plus 3. Divide that by 3. And they end up with 6.33. Now, even though the blue player only has 3 boxes and the red player has 6, the blue player ends up winning because they have a higher mean. So that's how we play mean boxes. This one plays out a little differently to the original boxes game. And remember, you can use a collaborative drawing tool like Aggie.io to play online if you want. So you just need to invite someone else to your page, and then you can draw up a grid and have a little game of boxes going. Happy gaming! I hope you've enjoyed this episode, and I'll see you on Friday. Bye.